Hello, everybody. Welcome back. So last week we covered MapReduce. Well, happy Monday. Last week we covered MapReduce, and today will be your first homework assignment and your first TA office hour. So what we are going to do today is to have your TA, Wei Wei. Wei Wei is here.
Hi, everyone.
Wei Wei is going to
well, to make steel, if you just use plain steel, it's very weak.
Yeah.
So you have to get this other tungsten and all this other cobalt and add a lot of that stuff into the steel to make it.
All right. Well, that conversation is actually very interesting, but I just muted. I think it's from one of you guys. So if you're not asking questions, please mute your mic. So Wei Wei is a PhD student in our lab in computer science, and her expertise is computer vision, geospatial data. She will be able to tell you more if you want. But today she is here. She's our TA. She's here to give you a lecture on Spark. So remember all the MapReduce things we talked about last week. Spark is an implementation of MapReduce. So you're going to use Spark for your homework assignments and for your final project in this class. Pay attention to what she will be showing you in the slides. And after the quiz, she's going to host the first office hour today at 8 p.m., I believe. If you have questions about homework assignments, that will be your time to ask. Okay. All right. So Wei Wei, you can start.
Sure. Let me share the screen first.
Oh, there are slides. Yes, we can see the slides. So Wei Wei can upload the slides to Piazza after during the break.
Of course. You mean after the class before the quiz? Or after the?
Well, if your presentation will be longer than 1 hour, you will take a break, right? Then you can.
Gotcha.
All right. So Wei Wei, you have the floor.
Yes. So first, so today I'm going to give you an introduction about Spark and the Spark framework and the Scala language. So as Yayi said, we're going to use Spark for all the assignments, and Scala language is an option for you, so you can get 10% bonus if you use the Scala language to finish the homework. So hopefully after this lecture, you will gain some basic knowledge about Spark, and it could be a good start point for the Scala language. So let's get started. So first is the general introduction about what the Spark is. So Spark is a cluster computing framework, and it allows us to do the computation in a set of nodes, which is a distributed system. And it have many applications. So here I give you some examples. First is the interactive SQL. So you can write something like SQL to access the data sets, to query the data sets. And the second is the real-time processing. And the bottom left figure here is an example. So you can see the flow chart here. And all these flow charts are plotted using the real-time data. And the third example is the streaming data analysis. So the bottom right figure here is an example. The streaming data here is the traffic streaming data in LA. And we can process the data and we can monitor the traffic in the real time by using the Spark. So this is a general introduction about Spark. And by the way, you can, if you have any questions, you can interrupt me anytime you want. So next is the big picture about the architecture of the Spark stack. Here you don't need to memorize any details in this figure. I just want to give you a general idea about the architecture of Spark. So it has 4 layers, and you can so the top layer is for the applications. What I just talked about. For example, the Spark streaming is for the streaming data analysis, and below the top layer is the most important module for Spark, which is called the Spark Core module. And in the Spark Core module, the most important is the resilient distributed datasets. And in this lecture, I'm going to spend a quite long time to introduce the RDDs. And below the Spark Core module is the job schedulers. Because the Spark is a distributed system, so the Spark needs the job schedulers to coordinate the work between the master and the worker nodes. And we're going to show the detail laterly. Before the bottom layer here is the data storage layer. So that it have multiple options. For example, it can do the Hadoop HDFS file, and it can also be the Amazon S3 file system, and even it can be your local TXT file. So next is the introduction about the resilient distributed datasets. So the RDD is the architecture foundation of Spark, and it's immutable in-memory collections of objects. If you see this figure here, we can see the RDD can split into multiple partitions, and each partitions can be processed.
Oh, sorry, wait. Can you go back to the previous slide?
Sure.
I want to talk about this slide. So in the meantime, can you upload the slides to
sure.
Piazza?
Sure.
All right, so I don't think we can.
I'm in the play mode, so.
Let me do this. I'll take a screenshot.
Okay.
And you can upload the slides. Let me share my screen. All right, so what I want to talk about here is, remember we had this MapReduce architecture last time, right? So we say in a MapReduce environment, you will have a distributed file system, right? That's the data storage layer. And we will have some map task. We will have some reduce task. And it's right here, reduce task. And what else do we have? Anybody?
Combiner?
Well, you do have a combiner running on the map machine. What else do we have? Well, you have this shuffling step, right? So if you look at this architecture, to be able to coordinate all this map task, reduce task, Remember, we say that all these machines will be able to access the distributed file system. And somewhere your system is handling this shuffling step, right? That's your job scheduler. And also you have a primary node that is going to ping your map task and map node and reduce node all the time to get the status, right? So if something wrong happened, it will need to restart the task. So that's your job schedule. And all the map reduce work is implemented here. And these are additional libraries that you can use. So these are very nice libraries. If you look at the machine learning library in Spark, there are clusterings that you can use, recommendation systems, they already implemented, and you'll be able to use them on a large data set. All right, I'll give this back to Weiwei.
I just uploaded the slides in the resource folder in Piazza.
Thank you.
So the next thing is the introduction about the resilient distributed data set. So here the figure shows that RDD can be split into multiple partitions and to process the data in different nodes in the cluster. So basically, RDD has two kinds of operators. One is the transformations and the other is actions. So before going deeper into these two operations, first we need to create an RDD, which is an entry point for all these operations. So the way we're creating the RDD is created from a Spark context object. And here, the top figure here is an example about how the command how to create a Spark context. And the Spark context can be viewed as your handle to the Spark cluster, and it's connect you between you and the Spark cluster. And there is two ways to create the RDD from the Spark context. One is the parallelized collections. And the bottom figure here is an example. It is so the first line is the Scala Scala variable, which is the list. And then the second line here is to create an RDD from the Scala list. So this is one way to create an RDD. And the other way is from the external data sets. So here is an example. You can read the TXT file directly from your local machine and convert it into a RDD. So this is how to create an entry point. So after we have a RDD, we can do the two kinds of operators on it. So first is the transformation, and the other is actions. So the return for the transformations is a new RDD, and and the transformations are lazy, and I'm going to use example to tell you why we see the transformation operators are lazy. And the other operation is action, and the return value for it is to compute the result based on the RDD. And they are eager, so the same, I'm going to use an example to show you why the actions are eager. So first is some common transformation operators. So first is the map. So inside the map, you can define the functions. And then the map operators will apply the function to each element in the old RDD and return a new RDD as a result. And the second is the common operators is flat map. So after applying this function, after apply these operators into the RDD, the returned RDD will be flattened. And I'm going to, in the next slide, I'm going to use an example to show you how the flat map work. And the third is the filter. So it's similar to the SQL language, like to filter, for example, to filter the height more than 1 meters. And the fourth common transformations is distinct, which returns which remove all the duplicates from the old RDD and return a new one without any duplicates. Do you have any questions so far? If not, I'm going to show you the example for the flat map. So here, if we read the codes, the first line is a list of string, and here we we create the RDD, use the parallelize option, and then we do the flat map. So here means that we split each string by the space. So so you can see if we print the flatten results. So this is all the each individual words here. So this is how the flat map works. So here is another example for the transformation operators. Here is distinct. So the same input data here is a list of strings. And after remove the duplicates, the last line here shows the results without any duplicates. So after the introduction about the common transformation operators, the next is the common action operators. So first is the collect. So it returns all the contents in the RDD. Next, I will use the example to show you what's the return all the contents in RDD means. And the second is count. So it's similar to the count function in like a Python language. For example, you have 10 words in the RDD, and by using the count, it will return 10, means that you have 10 words in the RDD. And the third is take. So which means it returns the first number elements of
Sorry,
RDD.
wait. There are questions in the chat.
Oh, sorry, I didn't notice the chat. Oh, so the question is this code of Spark language itself or some other programming language? So Spark is a framework, and you're going to write it. You are going to write like the Scala, Python, or Java, or R language to compute. So you are going to write the language to give the commands to the machine to finish your computation, to finish your task. So after introducing these action operators, I'm going to tell you how the Spark works, and then you can know, and then you will know like how the relationship between the Spark and the programming language. Does it answer your question? I take it as a yes. Thank you. Let me open the phone. Let me open the chart so I won't miss any questions here. So the next is the take, so means that it will return first number elements of the RDD. So for example, the number can be 10. So like you have 100 string. So the RDD will return the first 10 words in the RDD. And the next is reduce. So reduce function takes 2 elements as input from the RDD, and it will produce the output of the same type as the input elements. And one example is the summation. So we can sum two elements of the RDD and return the number. And so the last common actions is for each. So here you can define the function inside the for each, and the for each will apply the function to each element in the RDD and return the unit. So the unit is a data type in Scala, and it used as the return statement for function. Is similar to the void type in other programming language. So the application for the for each is that if we want to apply an operation on each element of the RDD, but we don't want to return the value to the master node. So for example, you want to process something in each individual work nodes, but don't want to return the value to the master, you can use the for each operator. So here is some example. Next is some examples about the common actions. So first is the count. Like you have the same example here, you have a list of strings, and first you flatten them and you remove the duplicates, and at last you count the number of words and it will return 8. So here is the another example. So the same, we have a list of strings, and we create a RDD and we do the map. So remembering the map, inside the map, we can define the function. So here is a function. The function here is to calculate the length of calculate the length of each words. So after apply the map operation, what will happen on the cluster? Do you have any idea? You can just speak out or put something. Yeah, yes. So someone answered in the chat. Yeah, yeah. So it will be. It won't have any operations happened in the clusters because of the lazy feature of the because the map is the transformation operator, and the property of the transformation operators is laziness. So there's nothing will happen in the cluster at this point. Yeah, good answers. So if we want this computation to be done, of course, we need to add an action. So here we add the reduce, and as an example, the summation is a simple function we can use in the reduce operators. So it will return the total number of characters in the RDD, which is the list of words. So here is an example about how the laziness of the transformation operators works. So next, let's see the benefits of this laziness. So here is an example. In this example, we are loading the log files, and we want to filter out. We want to find the top 10 figure files which contains the error. So the basic idea to if we process these operators in sequence, so first we need to fill out all the log files which including errors, and then we choose the top 10 from the filter results. But because of the laziness, so Spark won't won't filter out all the files including errors at the beginning. Instead, it will count like as soon as 10 elements of the filter RDD are obtained, it will stop the filter operation. So we can see using this laziness property, Spark can save time and space to compute the elements in RDD. So this is how the RDD looks, and the two operations in RDD. One is the transformation and the other is the actions. So the property of the transformations is laziness, and the property of actions is eagerness. So which means that the action operators will be implemented immediately, while the action operators only will be called if the action operators are called. So do you have any questions so far? If not, we will see how the Spark job will works. So this is the master worker topology, how it looks like. So on the top is the master nodes, and in the bottom is the multiple worker nodes. So usually in Spark, we refer the master nodes as a driver program, and inside the driver and we refer the worker nodes. We refer the worker as worker nodes, and the Spark context is located in the driver program. So which means you can write the Spark program inside the Spark context. So how you can use like the Scala, Python, or Java to write the Spark program. So this is the relationship between the Spark and the programming language. So you can see here is a gap between the driver program and the worker nodes. So how they connect, they are using the cluster manager. Remember the cluster manager is the third layer of the architecture of the Spark. And you have multiple options, for example, the Hadoop PR. So the driver program is like the brain of the Spark job, and it contains your main function created in the Spark context. And so the function of the Spark context is to connect your programs to the bottom worker nodes. So every Spark application usually has one driver program, and it can be launched in parallel operations on the cluster. And the driver program will have the main function of your application. So then it can send jobs to the worker nodes.
question.
Mhm.
So I remember us talking about the master node and how that also helps coordinate the primary node to coordinate the work amongst the worker nodes. I was wondering how the master node or the primary node fits into this context here too.
So like you write the program in the Spark context, and the driver program, which is also called the master nodes, to access the main function of your program, and then go through the cluster manager, assign the job to the executors in the worker nodes.
So does the driver node live on the master node?
Yes. So
Okay.
So in the Spark context, we refer the master nodes as a driver program. So
Okay, got it.
Mhm.
Thank you.
No problem. So here, let's go to the bottom part here, the relationship between the worker nodes and the executors. So the worker nodes is the nodes which runs the applications. You can see, you can view it as a machine. So the executors is the processors in the worker nodes. So it takes charge to run the individual task in for the Spark job given by the master nodes, the driver program. So after knowing what the driver program is, and how the Spark use the cluster manager to connect the driver program and the worker nodes, let's go through how the Spark program implemented step by step. So first, the driver program runs the Spark application, which is created in the Spark context. And then the Spark context connects the cluster manager to allocate the, and then the cluster manager allocates the resources. And then the Spark requires the executors to run the Spark program in each worker nodes. And then the driver program sends and after all this settle down, the driver program will send the program into the executors to do the implementation. So this is how the workflow for the Spark. Do you have any questions?
So this is also interesting. If you just run Spark on your machine, it will still run. That means everyone runs on the same node.
Yeah. So after this introduction, I will give you example like how the Spark can run your virtual machine, and you still need to assign the parameter for the master nodes. So you will see you can, for your local machine, you can assign the number of cores in your machine to the Spark program. So this is a example about how the cluster topology works with the simple program. So here you have a bunch of pairs, which is a name and age. So you create RDD, and here you do the action operation for each here, and here inside the for each operators, you define the function which you want. Here is the print, so you want to print the pairs of name and age. Yeah, because the for each is action operator, so the worker nodes will print the results. But remember the for each, do you remember the return value for the for each? So it will return, yes, the unit. So unit means it will return the void type. And so it won't return anything to the master nodes, but in each worker node, it will print out all the pairs of the name and age. So here is another example. The same data, the pairs of name and age, and for each is to print out the contents in the RDD in the worker nodes. So, so it's like the command in the Scholar. So in Python is print. So if you want to print something in so here the same we want to take the first 10 elements in the RDD. So remember we have the master and the worker topology. So here we need the connections between the worker nodes. So the master nodes will know it get 10 items in the pair of name and age. So this example show like the implementation of the action involves the communications between the worker nodes. So next is so this is the how the Spark works in the worker in the master and the worker topology. So the next is I want to show you more why the Spark is good for the data sciences, especially for the machine learning language.
Hello, Tia.
Sorry, machine learning. Yes.
Could you go back to the page 33? Yeah,
Yes.
and could you mention each code for the sample one by one, because I'm not familiar with the Scala. Thank you very much.
So so the first line is define the class, and inside this class is the pair of name and age. And then it create the second line is convert the Scala class into the RDD. And the third line here the for each is an action operator, and what it do here is to print out all the contents in the RDD in each work node. And the last line here, the tag operators will take the first 10 elements in the RDD. Does it clear to you?
So what's the relationship between the name and the age? Is that the key value pairs, or they are two?
So it can be a key value pair, but here I haven't seen any thing about the key value pair because it doesn't have the map reduce option operations.
So name and the age are just two variables.
Okay. Yes. So next is to show you an example about the properties of Spark is good it's good to implement the machine learning algorithms. So we all know the most of the machine learning algorithm involves the iterative learning. So the weights in the machine learning algorithm needs to update their weights during the iterations. So here is how the iteration works in Hadoop. You can see in each iterations, the input it has the operation to read and write the contents to the file system. So the read and write operation takes a long time. Instead of in the Spark, remember one property of the Spark is it will do all the computation in memory. So it saves a lot of time on the, so it doesn't need to read and write to the file system during the iteration. So it saves lots of computation, save the space and the time. And next, I'm going to use an example to show you use the linear regression as an example to show you how it works for the iterative algorithm. So here is so the figure here is an example for the logistic regression, and the goal for the logistic regression is to learn a hyperplane to separate the data in for here is to separate the data into two classes. So one class here we represented by the blue dots, and the other is represented by the red dots. So first, the top left figure here is the initialization, and we can see it cannot separate the data in the space. And after the iterative learning to update the weights in the hyperparameter, in the end, it can separate the data. So this is how, and next I'm going to show you how it updated the weights iteratively. So the W represents the weights in the hyperplane, and here G is the function to calculate the error of the given hyperplane and the data points X and Y. So we sum all the error together and multiply by a factor alpha, and then we update the weight vector according to the error, and then we use the new and then we update the weights according to the value in the right part. Do you have any questions about how the updates weights works? So the next is the sample codes to implement the logistic regression in Spark using Scala programming language. So first, the line here is to first is to read from the TXT file to load, which contains all the XY data points, and then to create a new RDD. So the first line here is to create a new RDD, including all the XY pairs. And the second line here is to initialize the weights for the hyperplane. And the second line here is to start the iteration learning. And the fourth layer is the gradient. So the gradient here is to calculate the let me use the annotation here. So so the gradient here. Sorry, let me go to the last slide. Yeah. So the gradient here is the implementation for this part, circled by the green line here. And then the reduce means that to sum of, sorry, is not included the alpha. here, the reduce means sum them up. And then we update the weights by time the gradient with alpha. So this is how the implementation of the logistic regression using Spark, using Scala and Spark.
I have a question.
Sure.
Yeah, what does alpha mean right here?
Oh, so alpha is the learning rate.
So you decide that rate, or is automatically decided by the Spark?
Oh, you decide the rate.
Okay, okay.
So it doesn't show here.
Okay.
There is a question in the two questions in the chart. The first is, does underscore represent each unit? Yes. So the unit means each element in the RDD. So remember, the reduce operators take two elements in the RDD as the input and return the element which is the same data type as the inputs. So we use the underscore to represent the elements in the RDD. Does it answer your question? So I can go to the second question in the chart. Yes, I think so the second question is he thinks the Scala is hard to follow. If you can, so I think at the beginning to learn something is a little bit hard, but at least I want you can like to understand the results in each line here. I think this is the goal to using the Scala sample here.
It's not, if I may, it's not because of Scala. It's this Python, this Spark libraries aren't just not that easy to understand. So if you look at the reduce, so many times you can do map reduce in one line, and it will accomplish many things. So that's why this might look very difficult to understand. So even if you use Python, it will be still the same. You can use PySpark for your assignment.
Yes. So I will talk about more about the homework details in the end of the lecture. There's one more question. So the first, there were two more questions. So first is, explain what reduce does here again. Oh, so the reduce here is to sum up all the value of the G function together. So here first, let me break down here. So first, the points, remember the points is RDD contains all pairs of X, Y, and then do the map option operators. So the inside the map operators, it applies a function G here. Like the P is the XY pair, and the G is to calculate the error between the hyperplane and each data point here. So this is one. So the map here is to calculate the G function. And next is the reduce, is this summation symbol here is do sum all the G values together, and this is the gradient. Yes. So you can you can define the function in the reduce. Here the function you define is the sum. You can also define like the multiplication. You can define other functions. Yes, you can also like in the chat. Yeah, you can also do the other operators like multiplications in the reduce function. Sorry, there are too many questions in the chart. So after the questions about the reduce, the next is how do we decide alpha in practice? So alpha is the rate. So basically if the so this is the hyperparameter you need to define. You need to set the value, and if the value is too high, so you may miss the optimal weights. So usually it's better to set it small, because small it may need more iterations, but you can get high chance to get the you can get the optimal solution. But it's the hyperparameter, so you need to do some experiment to see what's the best range for the alpha, and it also depends on the data sets. So different data sets will have different alpha value. Oh, so the next question is what's the difference between PySpark and writing Python in Spark? So if you want to use the Python programming language for the Spark, you need to install the PySpark packages. And in the end of the lecture, I will show you how to install it. So the next question is reduce the execute options you define. So reduce is action operator defined by Scala. Yeah, so it's not defined by myself. Yeah, I think I answered all the questions in the chat, so we can move to the next slide. So there is a weakness in this code. Can anyone find it? I think even at the first time, it's a little bit hard for me to find it. So let's. So, so you can see here is a transformation and action pair here. But if you see the first line here, we have one more transformation operator here. So, which means that the points will be re-evaluated upon every iteration. So maybe re-evaluate is a hard word to understand. So which means like every time we need to create a new RDD for each iteration, so it's kind of waste. So for this problem, Spark has a caching and persistence mechanism. So these two operators is the optimization technique in Spark for the iterative learning. So using the cache and the persistent methods, and it can keep the RDD in the memory, and if it's too large, so the cache function will keep the RDD in the memory, and if it's too large, it will keep the keep the RDD in the both memory and disk. So which means that instead of create a new RDD in each iteration, this RDD will keep in the memory for all the iterations. Do you have any questions? So if not, so here is the updated version for the logistic regression implementation. So instead of using map
Sorry,
in the—
I just want to interrupt a bit here. So guys, you want to pay attention to all these commands that will allow you to store data in the memory instead of in the disk. Right? So when we talk about the lazy command and actions in writing Spark, writing code to interact with Spark, you want to be able to minimize the disk read and write so that your code will be able to run more efficiently, because reading, like we said, reading from disk or write to disk is very time consuming. In your homework assignment 2, your goal is not just to write a program that can run. You will need to be able to run your program within a time limit. So all this becomes important. You don't need to get it right now, but just keep in mind that this might be something that you want to revisit once you start your homework assignments. Okay, well, you can continue.
Yeah, so like in the persistent function, you have two options. One is memory only, and the other is memory and disk. So by default, it's memory only. So it will keep the RDD in the memory. Yeah, so this is the updated version for the logistic regression implementation. So replace the map in the map function in the first line with the persist. So the RDD will cache in memory, and it can be reused in all the iterations. So again, the laziness of the RDD is the benefits of the Spark. So which makes so the laziness property makes Spark is faster on the computation. But to really fully take the advantage of the speed in Spark, you need to know you need to avoid the recomputation in several during the iterations. So here is the summary about the RDDs. So I listed all the properties of the RDDs. So first is resilient, is also the first word of RDD, which means RDD is fault tolerant, because it's in the distributed system. So if one worker node is missing or broken, the Spark can recompute the missing or damaged partition due to the resilient property. And the second is the distributed. So we just saw the master worker topology in the Spark, which means it's the distributed system. And in memory, we just saw it logistic regression implementation. So they do the computation all in the memory, which makes Spark much faster than Hadoop. And we will compare the Spark and Hadoop in the following in the next slide. And the fourth is immutable, which means after you create a RDD, you cannot change it. So you cannot change itself, but if you want to change the contents in the RDD, you can use the transformation operators to get a new RDDs. And the next is the laziness. So it's means that which is the property of the transformation operators. And the next is catchable. So we just solve the persistent and catch function. And parallel, so it does the computation parallelly in the worker nodes. And the partition, so remembering the first slide introduced the RDD. So RDD can be split into several partitions and send them into different worker nodes to process the program. And the last is the location stickiness. So which means that RDD can define the partitions as close as possible to the data. And the advantages of design the locations of the partition is to reduce the time for the network communication. So because like remember the example for the tech operator, so it returns the first 10 elements in the RDD, but it's processed in the different worker nodes. So different work nodes need to make connections to do the communications. So the master nodes will know it gets enough 10 items in the RDDs. So the advantages of local stickiness is to reduce the network communication time. Do you have any questions? So this is all I want to say about the RDDs. Comparison between Spark and Hadoop. So the biggest advantage of the Spark is the running time. So we can see this is a figure provided in the Spark official website, and using the logistic regression, the running time for the Spark is like 100 times faster than Hadoop because of the laziness property and the in-memory calculation. Sorry, the most important is the in-memory calculation. So it don't need to read and write into the disk during the iterations. So the next is some other advantages of Spark. So you can write program in 4 language. They are Java, Scala, Python, and R. And it can run everywhere. So remember, we saw the architecture of the Spark stack. So you can use different, the top layer is the application, like you have the machine learning library, you have the streaming data analysis tools, and the second layer is the RDD, and the third layer is the cluster manager. So you can use different cluster manager, plug in the Spark architecture, and the bottom layer is the file system manager, and you can also use a different file system manager. So that's why I say the Spark can run anywhere. And the last advantage here is the generative. So it can like combine the SQL, the streaming data, and do some, and it's easy to implement some machine learning algorithms. So this is all the introduction about Spark. Do you have any questions? If not, I'm going to give you a quick introduction about Scholar, and then have some instructions about how to install Scholar and the version we required in the homework. Why do we need collect after flat map? Do you remember which slide? Maybe I can. Okay. So CLAC is so sorry. Oh yeah, it's slide 9. Sorry, the question is why do we need collect operation after flatten map? So the collect means return all the contents in the RDD. For example, if the RDD is a list of the string, so let's just use this example. So here is a list of string, and the flat map, they split each string into individual words. So here is the results, and for collect means that this can be processed in the worker nodes, and then the collect will return the splitting results, the flattened results into the master nodes. Does it answer your question? Yeah, so it collect return all the items in the RDD. Okay, so the next question is, could you talk more about how Spark get faster than Hadoop from the structure level, like the use of the workflow in our textbook? When you say workflow, do you mean map reduce?
Yeah, I think this is something related to the structure of Spark.
So like a structure, you mean like the master worker topology, or?
Yeah, I mean, could you talk more about how the Spark gets faster than the Hadoop framework? Because I'm not at your point during the presentation for this one.
Oh, so I think your question is so like why Hadoop is faster? Oh, sorry, Spark is faster than Hadoop.
Yeah, I understand that you use some functions like persist and cache, but I'm not sure whether there are any other advantages to help Spark to get faster.
Oh, so like in each iteration for Hadoop, it needs to read the data from the file system and then write the results into the file system. So the read and the writing of the interaction between is the interaction to the input and output takes time. But for the, so you can see here in the Spark, it do all the, so it updates like the weights in the logistic regression in memory. So it doesn't need to interact with the input output system.
So the shuffle process will also be performed in the main memory.
I think so. Yao, do you have anything you want to explain here about the
difference between Hadoop and Spark?
Like where the Spark doing the shuffle operation?
I don't know. Well, we would guess it will be in memory, but it depends.
I think
thank you.
I think I can do some research. Maybe I can post the, if I find the answer, I can post it on the Piazza. Does it sound good?
Yeah, thank you so much.
No problem. So next thing is the Scala. So here I'm going to give you a short introduction about Scala, and then is some instructions about how to install Scala and some version requirements for the assignments.
Okay, so we're probably running out of time, but before you talk about Scala, let me share this in the chat. So this is a very nice course on Coursera. It's about Spark and Scala. So the reason why I know it's very good because I took the course. I finished all the assignments within the spring break. We don't have a spring break this semester, but I highly recommend you to look at least the course content. And when you have time, take the course. When I took it, it was free. I think it's still free. All right, but one thing before we will talk about Scala, Scala is a programming language that people are commonly used to access libraries in Spark. And the reason why I think Scala would be important for you, because you might think, I already know Python, why do I want to know Scala? So when you start to implement your homework assignment, or when you get a real job and start to write code to interact with big data set, writing in Python would usually give you, you will usually use the same thinking logic to write code. For example, let's say if you want to be able to generate, to loop through one array and generate all the permutations of size 2, right? That means you have to loop through the array once and second time. But that takes a lot of time because you have lots of for loops. And remember, when we talk about MapReduce, the overall goal is to be able to parallel process many of these things, right? So if you use Scala, it gives you a new perspective. You don't really write for loop twice. You start to think about, how do I write this more efficiently? How do I use MapReduce to be able to run this more efficiently? Okay, so we probably have 5 minutes to finish this. And for the installation, if you don't have time, you can do it in the office hour, but just remember that you record it and post the recording on Piazza. And I think you have another office hour this week, right? Because we have students in a different time zone, and you can do the same for that office hour.
Sure. So
if you're going to explain it twice, then you don't have to post recording unless people want to see it.
Okay. So since I only have 5 minutes, I just go through the slides. So there's some instructions about how to find the the version for the Spark we are going to use in the homework, and like to install the Scala and how to settle the Spark environment, and to build the jar package for the Scala. So, and also to install the PySpark, and some examples about how to run the program in the command line. And I just want to say something about the version. So you need to install the specific versions I listed here for all the assignments, because we are going to use the backroom for the grading. And so we are using these versions for grading. So if your codes have any, because of the version conflicts, your code cannot be run in the vocal room. So we don't accept regrading in this case. So this is all I want to say today.
All right, thank you, Wei Wei. So in the office hour, you are going to cover how we will be able to use, well, install Spark on the machine, right?
I don't fully understand you. So I will like recording a video, go through working through video, posted on the Piazza for the
Right,
rest of.
because you ran out of time. You still have some content that you want to share with everybody, right? So if you're going to do that, you need to post a recording.
Okay, gotcha. Yeah, I will record the rest of the slides and post it on Piazza.
Thank you, Wei Wei. Very nice. Okay. All right, guys, you have 2 minutes until your quiz, so you can take a break and come back for your quiz. The same thing, you download from Blackboard, you upload to Blackboard, turn on your camera when you do your quiz, and you have 30 minutes.
Okay. And my first office hour is after the quiz from 8 to 9. So you are welcome to go to my office hours. I think the quiz is starting now. Can all of you open the camera? I think we still have 5 people haven't opened the camera. I think you can start the quiz now.
but this is very slow.
There are two questions in the chat. So first is, I think if the space is not enough to write down your answers, maybe you can, yeah, you can use the empty space in the end of the second page. The second question is for question 4 and 5. Can I use a specific example to answer the questions? I think that's your choice. Oh, I think you can use the extra page and so you can submit 3 pages for your solutions. So for question 4 and 5, I think you need to give an answer for the general cases. Maybe you can use an example to show that your pseudocode or your MapReduce program works. So the students say like 2 times 2 matrix is specific enough to write out all the elements. But based on my understanding, you need to define the operators for the map and reduce physics. Let me double check with Yao Yi. For question 4 and 5, I just confirmed with Yao Yi, so you need to use IJK for the solutions. You have 2 more minutes. I think time is up, so you can submit your solutions in Blackboard. And thank you everyone for attending today's lecture, and my office hours will be held in 10 minutes. See you guys.